The ground beneath your feet is the most profound illusion in the universe. It feels solid. It feels stable. It is the very definition of stillness. Every instinct you possess, every message your senses deliver screams a single, simple, and utterly convincing falsehood that you are stationary. This feeling is the bedrock of our experience, the foundation of our sanity. But it is a lie, a magnificent cosmic deception. Right now, at this very moment, you are a passenger on a colossal sphere, a world of rock and water cloaked in a thin veil of air, hurtling through the absolute zero vacuum of interplanetary space. You are caught in a whirlwind of motion so complex, so layered, so relentlessly violent that your mind struggles to grasp it. The silence of this journey is its greatest trick. There is no rush of wind, no rumble of a cosmic engine. The frictionless void offers no resistance, no clues to our incredible velocity. We are like travelers in a perfectly smooth, silent vessel, convinced of our immobility while we cross an entire ocean. Let's pull back the curtain on this illusion just for a moment. If you are near the equator, the ground you perceive as motionless is currently spinning at over 1,000 miles per hour, a rotational velocity faster than the speed of sound. Every single second you are transported nearly half a kilometer to the east. You are swept along in a silent planetary pirouette of immense power, yet you feel nothing. The air moves with you. The oceans move with you. The entire world is locked in this colossal coordinated spin. It is the gentle turning of this cosmic carousel that gives us our days and nights. The slow, steady rhythm that has governed life for billions of years, but this daily spin is just the beginning. It is the smallest of the dances. This entire spinning sphere, our Earth, is also locked in a much larger orbit, a grand annual pilgrimage around a star of searing nuclear fire. Our Sunday, to keep this appointment to remain bound by the Sun's immense gravity, Earth courses along its orbital path at a staggering speed, 67,000 miles per hour. That is not a speed you can easily visualize. It is nearly 30 kilometers every single second, a velocity so extreme it could cross the continental United States in minutes. Every year of your life, you complete a journey of nearly 600 million miles. You travel through the darkness, a silent celestial nomad, and you end up right back where you started to begin the epic voyage anew. And still, this is not the complete picture. The truth is even more intricate. Our sun itself, this anchor of our solar system, is not stationary. It too is a traveler. It drags the Earth and all the other planets with it on an immense sweeping arc around the center of our Milky Way galaxy. Our collective speed on this galactic circuit is almost unimaginable. Roughly 500,000 miles per hour, 500,000 miles per hour through the stellar void. We are all adrift in a river of stars, a celestial current that takes over 200 million years to complete a single lap. Every certainty you have ever held is built upon a foundation in constant cascading multi-layered motion. So why does it feel like we are standing still? Because everything else is moving with us. The secret is relativity. The sun is our local anchor. The distant stars are galactic reference. Our senses, evolved for survival on a planetary surface, are simply not equipped to perceive the grand cosmic ballet. They are designed to notice the rustle in the grass, not the planet's spin, to feel the warmth of the sun, not our orbital velocity around it. This documentary is the story of how we overcame our own senses. It is the chronicle of a magnificent intellectual struggle against the most powerful illusion in our experience. It is the tale of how humanity, generation by generation, painstakingly pieced together the hidden truths of our planet's motion. We will journey back in time to an era when the stillness of the Earth was not just an assumption but an article of sacred faith. A time when the sky was a dome and the stars were fixed points of light. a time when the very idea of a moving Earth was heresy, a profound violation of common sense and divine order. The quest to understand how Earth moves is not a simple story of one great hero having a single revolutionary idea. That is a myth, we tell ourselves. The reality is far more subtle, more human, and infinitely more compelling. It is a story of forgotten geniuses, of unsung observers, of scientists whose names are not written in headlines. We call them the sleepy scientists, not because they lacked energy or passion, far from it, but because their work was defined by a quiet, relentless patience, a patience that could span an entire lifetime or even multiple generations. These were the keepers of the long view, the astronomers who would spend 40 years charting the slow drift of a single star, the geologists who saw the story of 1 billion years in a layer of rock, the mathematicians who filled entire libraries with calculations to find a tiny, almost imperceptible wobble in our planet's axis. Their laboratories were often cold, lonely mountaintop observatories. Their tools were brass and glass, paper and ink. Their discoveries were not explosive breakthroughs, but slow dawning revelations. They were listening for whispers in the cosmic noise, searching for anomalies, for numbers that were slightly out of place. They were hunting for the gentle clues the universe leaves behind for those patient enough to look. Their work was to notice the almost unnoticeable, to measure the immeasurably slow, and in doing so they constructed piece by painstaking piece the most revolutionary vision of our world ever conceived. They showed us that our planet doesn't just have one or two simple motions. It is a symphony of complex, interwoven movements. There is the daily spin, the first and most obvious motion, the primal rhythm of our world turning us toward and away from the sun's light. But how did we first prove we were spinning? How could you demonstrate that the Earth itself was turning when everything you saw seemed to suggest the sun was moving across the sky? The answer involves a pendulum, a cannonball, and a profound shift in thinking. It is a story of seeing the invisible forces that govern our world. Then there is the great annual pilgrimage, our orbit around the sun. For millennia, we placed ourselves at the heart of creation. The sun, the moon, the planets, and the stars all revolved around us. It was the ultimate story of our own importance. Toppling that idea was perhaps the single greatest intellectual leap in human history. It was a cosmic demotion. It required us to abandon the evidence of our own eyes and place our faith in the elegance of mathematics. We will uncover the story of the forgotten maps and forbidden books that slowly, quietly nudged our world from the center of everything. But the story does not end there. The sleepy scientists kept looking, they kept measuring, and they found motions far more subtle, movements so slow they are imperceptible on the scale of a human life. They discovered that our planet wobbles. Like a slowing, spinning top Earth's axis traces a huge, slow circle in the heavens. A single wobble takes nearly 26,000 years to complete. This is the great precession of the equinoxes, a slow, celestial sigh. This motion is responsible for shifting our pole star over vast ages. The star that guided ancient sailors will one day be just another point of light replaced by a new celestial beacon. Uncovering this epic millennial wobble required connecting ancient observations from civilizations thousands of years apart. It demanded a trust in the records of long-dead astronomers, a scientific conversation that echoed across the chasm of centuries. It is the ultimate testament to patient generational science, and even this is not the full story. The most shocking discovery of all did not come from looking at the stars. It came from looking at the very ground we stand on. The sleepy scientists found that the illusion of stillness was double-layered. Not only is the planet hurtling through space, but the surface of the planet itself is in constant creeping motion. The continents are not fixed, the mountains are not permanent, the oceans are not eternal. The very bedrock of our world is broken into immense tectonic plates, colossal rafts of crust floating on a sea of molten rock. These plates are grinding against each other, pulling apart, colliding. This is a motion measured not in miles per hour but in inches per year, a speed so slow it is comparable to the growth of your own fingernails. Yet over the immense timescale of geology, this creeping dance is relentless. It is a force that builds mountain ranges, rips continents asunder, and gives birth to new oceans. The ground we call solid is a fleet of geological vessels on a slow, epic journey. To find this motion, scientists had to learn to read the planet's memory. They found it in the magnetism of ancient rocks, in the uncanny fit of coastlines separated by thousands of miles of water, in the fossilized remains of tropical plants found in the frozen Arctic. They were detectives at a cosmic crime scene 1 billion years old. Each of these discoveries, the spin, the orbit, the wobble, the drift, was a revolution in its own right. Each one chipped away at our intuitive, common-sense view of the world. Each one revealed a universe that was grander, older, and more dynamic than we had ever dared to imagine. And each discovery was brought to us by these patient, quiet observers. They were not seeking fame or glory. They were driven by a profound, unquenchable curiosity, a need to understand the fundamental machinery of the cosmos, a desire to know our true place within it. Their legacy is the world you live in today, a world where we can predict the tides with perfect accuracy, where we can navigate our globe with satellites that account for every subtle motion, a world where we understand the deep forces that shape our planet, from the quaking of the ground to the slow march of the ice ages. Their story is the story of science itself, not as a series of sudden eureka moments, but as a slow, cumulative, and deeply human enterprise. It is a testament to what we can achieve when we observe carefully, think critically, and have the courage to question our most cherished assumptions. It's a story of collaboration across vast stretches of time. A Greek astronomer in the ancient library of Alexandria makes an observation of a star's position. 2,000 years later, a scientist in a modern observatory uses that ancient data point to confirm a theory about Earth's slow wobble. A conversation unfolds not between two people, but between two eras. Knowledge becomes a tapestry woven with threads from countless hands. This is the journey we will embark on together. We will meet these sleepy scientists. We will stand in their observatories. We will peer through their telescopes and read their dusty notebooks. We will relive the moments of quiet frustration and breathtaking revelation. We will learn to see the world not as our senses perceive it, but as it truly is, a dynamic, breathing, moving entity, a magnificent celestial vessel on an extraordinary voyage. So prepare to question the very ground you stand on. Prepare to feel the silent rush of our cosmic journey. For we are about to unravel the great illusion, and in its place discover the stunning, moving truth about our home planet. The story of how Earth moves is, in the end, the story of how we learn to think. It is the chronicle of our awakening to the universe. Listen, feel the stillness beneath you, the profound, unshakable solidity of the world. It is the most fundamental truth of your experience. The ground does not yield, the horizons do not rush away. Everything you have ever known, every step you have ever taken, has been upon a stage that is utterly, perfectly motionless. This feeling is a deep and ancient inheritance. It is a comfort woven into the very fabric of our consciousness, a primal certainty that we are the stable center of all things. And for nearly all of human history, this feeling wasn't just a feeling. It was the unimpeachable truth. It was the foundation of our philosophy, our religion, our science. It was the linchpin that held the entire cosmos in a state of sublime, perfect, and understandable order. The great cosmic drama we believed unfolded for us, around us. But what if the most obvious truth of your existence was a grand illusion? What if the bedrock of your reality was actually a phantom? This is the story of how we awoke from that beautiful dream. It is the chronicle of a monumental struggle to prove the impossible, to show that the firm ground beneath our feet is not a foundation at all, but a vessel adrift and spinning on an endless cosmic ocean. Before telescopes, before satellites, before the cold calculus of physics, there was only the sky. And the sky told a magnificent, simple, and deeply personal story. Imagine yourself there, thousands of years ago, on a clear, moonless night. You look up into a velvet darkness pierced by 1,000 diamond shards. What do you see? You see a grand celestial sphere, a majestic dome arched over your world like the roof of a divine cathedral. Night after night, this entire dome appears to rotate. Constellations wheel in a slow, silent, and predictable procession. The great celestial machine turns with the precision of a master clockmaker. During the day, a brilliant, life-giving sun traces a similar arc rising from one horizon and setting upon the other, a fiery chariot making its daily pilgrimage across the heavens. The moon, a pearlescent and changeable companion, follows its own path, waxing and waning in a rhythm so reliable you could set your calendar, your festivals, and your life by it. Everything in the firmament was in motion, everything that is except you. The earth, your home, was the one point of stillness in the universe. It was the anchor, the nexus, the absolute center around which all of this heavenly splendor revolved. This wasn't an arrogant assumption. It was a conclusion born of pure reason, drawn directly from the evidence of the senses. No one felt a cosmic wind. No one was thrown from their feet by a planet lurching through the void. The world felt stable, permanent, and central because, by all appearances, it was. This geocentric vision of the cosmos offered more than just an explanation. It provided a profound sense of place, of meaning. If we were at the center, then the universe was not a cold, indifferent expanse. It was a home built for us. The stars, the sun, the moon, they were not distant alien objects. They were features of our celestial neighborhood. Their light and motion are part of a story in which humanity played the leading role. This idea was a philosophical bedrock. It affirmed our importance, suggesting that our lives, our struggles, and our triumphs were not insignificant accidents in an infinite void, but the very purpose for which this grand cosmic stage was constructed. The heavens were a mirror, reflecting our own significance, and for centuries this beautiful, orderly, and human-centric universe was the only one we knew. It was a cosmos of profound comfort. But even in a perfect story, there are details that don't quite fit. Among the fixed and orderly stars, our ancestors noticed a few rebels, 5 bright points of light that refused to march in lockstep with the rest of the celestial sphere. They wandered. The Greeks called them planetes, the wanderers: Mercury, Venus, Mars, Jupiter, and Saturn. They drifted against the backdrop of the constellations, their paths complex and sometimes maddeningly unpredictable. Most bizarre of all was a phenomenon they called retrograde motion. A planet journeying across the sky would inexplicably slow down, stop, and then begin to travel backward for a time before resuming its forward course. It was a flagrant violation of the smooth, circular perfection that was supposed to govern the heavens. How could this be? How could you reconcile this chaotic celestial behavior with the idea of a perfect Earth-centered cosmos? The problem was a cosmic puzzle of the highest order, and it would take one of the greatest minds of the ancient world to construct an answer so ingenious, so mathematically elegant, that it would lock our planet into its stationary place for another 1,500 years. His name was Claudius Ptolemy. Living in the 2nd century in the city of Alexandria, a crucible of ancient knowledge, he was not just an astronomer. He was a geographer, a mathematician, a master synthesizer of thought. He inherited a universe of ideas, a collection of Greek astronomical models, and set out to build a definitive system. a system that could account for every last celestial anomaly, a system that could not only describe the movements of the heavens but predict them with astonishing accuracy. The masterwork he produced was the Almagest, a title that simply means the greatest, and it was. It was one of the most ambitious and influential scientific texts ever written. In it, Ptolemy took the intuitive geocentric idea, the Earth at the center, and transformed it from a simple picture into a full-fledged mathematical machine of breathtaking complexity. His goal was to save the appearances to create a model that precisely matched what could be seen in the sky every night. And the key to his entire construction, the elegant solution to the problem of the wandering planets, was a beautifully strange concept, the epicycle. Imagine a planet not orbiting the Earth directly. Instead, Ptolemy envisioned the planet moving in a small circle, the epicycle, and the center of this small circle in turn moved along a much larger circle around the Earth known as the deferent. It was a celestial dance of wheels within wheels. This ingenious device was the master key. As the planet spiraled along its epicycle while the epicycle itself was carried around the Earth, its path, as seen from our vantage point, would create a loop. This loop was the explanation for retrograde motion. The backward drift of Mars was no longer a violation of cosmic order. It was the predictable result of this intricate nested motion. It was a mechanical illusion, and Ptolemy had found the gears behind it. But even this wasn't enough to satisfy his quest for precision. The observed speeds of the planets still weren't quite right, so he added more layers of complexity, more brilliant refinements. He offset the Earth slightly from the center of the deferent. He introduced another point, the equant, from which the speed of the epicycle's center would appear constant. The system grew ever more elaborate. It became a dizzying assembly of celestial clockwork, a cascade of circles, offsets, and calculated speeds, all calibrated to perfection. And the result was nothing short of miraculous for its time. Ptolemy's model worked. It could predict the positions of planets years in the future. It could forecast eclipses. It could generate tables of astronomical data so reliable that they became the undisputed authority for astronomers across Europe and the Islamic world for a millennium and a half. His universe was a triumph of intellect. It was a grand, majestic cathedral of the heavens built from the pure logic of geometry. And at its heart, its unmoving foundation, lay the Earth. Ptolemy's system was not the product of simple-minded thinking. It was a monumental intellectual achievement, a testament to the power of the human mind to find order in chaos. It enshrined the Earth in the center of the cosmos, not through faith alone, but with the full force of mathematics and observational evidence. His model didn't just seem right, it felt right. It confirmed our deepest intuitions about our own stillness and our own importance. It gave us a universe that was complex yet ultimately knowable, a cosmos that was a home designed with a place just for us. And with the authority of the Almagest, the case for a stationary Earth seemed closed, the verdict of science and philosophy delivered. For the next 15 centuries, to imagine the Earth in motion was not just to challenge an astronomical theory, it was to question the greatest scientific mind of antiquity. It was to argue against the evidence of your own senses. It was, for all intents and purposes, to argue with reality itself. Yet even in the brightest glare of certainty, shadows of doubt can linger. Long before Ptolemy constructed his celestial fortress, long before his ideas became doctrine, a few lone voices in the ancient world had dared to whisper a truly radical, almost unthinkable thought. Centuries earlier, in the vibrant intellectual world of ancient Greece, philosophers were engaged in a fearless exploration of the cosmos, unbound by dogma, armed only with logic and observation. They debated the shape of the Earth, the nature of the stars, and the fundamental architecture of reality. And in this fertile ground of inquiry, one man proposed an idea so far ahead of its time that it would be dismissed as absurdity and almost completely lost to history. His name was Aristarchus of Samos. He was a brilliant mathematician who lived in the 3rd century BCE, a contemporary of Euclid. We know little about him. Most of his work is gone, surviving only in fragments and in the writings of others who often mocked his ideas. But what survives is the echo of a revolutionary mind. Aristarchus was captivated by the sun and the moon. He set out to do something unprecedented, to measure their sizes and their distances from the Earth using the elegant power of geometry. His methods were ingenious, though his tools were primitive, leading to inaccurate results. But the numbers were not what mattered. What mattered was the conclusion they led him to. He calculated that the sun was not just a little bigger than the Earth, it was monstrously, colossally larger, a vast titanic ball of fire that dwarfed our world completely. And this single realization, this shift in cosmic perspective, sparked a question in his mind that would change everything. If the sun was so immense, so overwhelmingly dominant, then did it truly make sense for that gigantic body to be orbiting our comparatively tiny planet? Wasn't it far more logical, more elegant, more mechanically sound for the smaller object to revolve around the larger? From this kernel of logic, Aristarchus proposed his breathtaking hypothesis. He suggested that the sun, not the Earth, was the true center of the universe, that the Earth was just another planet, one of several, all of them orbiting the central fire of the Sunday, and that the daily rotation of the celestial sphere was an illusion caused by the Earth itself, spinning on its own axis once a day. In a single stroke of intellectual audacity, Aristarchus had dismantled the comforting human-centric cosmos and sketched the basic architecture of the solar system we know today, 2,000 years before it would be proven. It was a moment of staggering genius, a leap of imagination so profound that it flew in the face of all experience, all tradition, and all common sense. And for that very reason, it was swiftly and comprehensively rejected. His contemporaries, even the most brilliant among them, could not accept it. They raised powerful, logical, and scientifically valid objections that Aristarchus and his followers had no way to answer. The first and most damning was the problem of stellar parallax. The argument was simple and devastating. If the Earth truly travels in a vast orbit around the Sun, then our perspective on the stars should change over the course of a year. Just as a nearby tree seems to shift its position against a distant mountain as you walk past it, the nearby stars should appear to shift against the backdrop of more distant stars. This apparent shift is called parallax. The ancient astronomers looked for it. They strained their eyes using the most precise instruments they had, and they saw nothing, no shift, no change whatsoever. The constellations remained rigidly fixed year after year. The only possible conclusion based on the evidence was that the Earth was not moving. They could not possibly conceive of the alternative that the stars were so unimaginably, incomprehensibly far away that the parallax shift was too minuscule for the naked eye to ever detect. The scale of the cosmos was simply beyond their imagination. The second objection was a matter of physics, or what we feel every day. If the Earth is spinning on its axis at a tremendous speed and hurtling through space in a massive orbit, why don't we feel it? Why isn't there a perpetual howling gale force wind as the atmosphere is left behind? If you throw a stone straight up into the air, why does it fall back to the same spot instead of landing hundreds of feet away as the Earth rushes on beneath it? These were not foolish questions. They were profound physical puzzles. Without the concept of inertia, the idea that an object in motion stays in motion, the notion of a moving Earth, seemed to contradict the direct observable laws of nature. Aristarchus's idea was not just philosophically unsettling. It appeared to be scientifically falsified by the best evidence available. So his heliocentric whisper was dismissed. It was branded as a curious, even impious absurdity, a flight of fancy from a geometer who had perhaps spent too long with his head in the clouds and not enough time with his feet on the solid, unmoving ground. The idea vanished into the intellectual ether, a footnote in the history of thought. The world would continue to sleep peacefully and contentedly at the heart of Ptolemy's perfect universe. And so the great geocentric model was not just preserved, it was sanctified. As the centuries passed, the ideas of Ptolemy and the ancient Greek philosopher Aristotle were woven together into a single cohesive tapestry of reality. This synthesis became the philosophical and scientific foundation of medieval Europe. It was more than just a theory of astronomy. It was a complete cosmology, a grand narrative that explained everything from the trajectory of a falling stone to the nature of the divine. In this worldview, the Earth was not just physically central, it was metaphysically unique. It was the realm of change, decay, and imperfection. Everything below the moon was made of 4 elements: earth, water, air, and fire. The heavens, by contrast, were perfect, eternal, and unchanging. They were made of a 5th element, the ether, and their natural motion was the perfect circle. This tiered universe was a reflection of a spiritual hierarchy. Earth was at the bottom, the realm of flawed humanity. And as you ascended through the crystal spheres of the planets, the Moon, Mercury, Venus, the Sun, Mars, Jupiter, Saturn, and then to the sphere of the fixed stars, you were climbing a ladder toward the divine. Beyond the final sphere was the Empyrean, the dwelling place of God. The entire structure of the cosmos was a physical manifestation of the great chain of being. To challenge the Earth's position at the center was therefore not merely an astronomical disagreement. It was an act of profound disruption. It threatened to shatter this entire beautifully ordered structure. If the Earth was just another planet, a wandering star like Mars or Venus, then what became of the fundamental distinction between the corruptible terrestrial realm and the perfect, incorruptible heavens? If the Earth moved, it implied the heavens were not a separate divine domain, but were made of the same stuff as our own world. This was a deeply unsettling, even heretical proposition. The stationary Earth was the anchor for this entire philosophical system. It guaranteed our special place in creation. It confirmed a universe built with a clear purpose and a clear hierarchy. To set it in motion was to cast humanity adrift in a cosmos that might not have a special place for us at all. It was to suggest that we were not the audience for which the cosmic play was being performed, but perhaps just minor actors on a provincial stage. The geocentric model became an article of faith, defended by the highest intellectual and religious authorities. It was a fortress of certainty, its walls built from the intuitive evidence of the senses, mortared with the sophisticated mathematics of Ptolemy, and buttressed by 1,000 years of philosophical and theological tradition. Inside this fortress, humanity could feel secure. The universe, while vast and mysterious, was ultimately a human story. The ground was firm, the heavens were orderly, and our place was secure. But no fortress, no matter how strong, can stand forever against the relentless tide of evidence. The universe is under no obligation to conform to our desires for comfort or our need for importance. The elegant clockwork of Ptolemy's heavens contained hidden flaws, tiny errors in its predictions that would accumulate over the centuries like grains of sand in a flawless machine. The ancient questions, the ones that had bothered Aristarchus, had never truly vanished. They lay dormant, waiting for a new kind of observer, waiting for new ways of seeing, waiting for minds brave enough to once again challenge the stillness of the world. The stage was set for a revolution that would not be fought with swords but with telescopes, not with armies but with equations. It would be a battle for the very nature of reality against the most deeply entrenched idea in the history of human thought. The grand, comforting dream of a stationary Earth was nearing its end. A new, more challenging and infinitely more magnificent cosmos was waiting to be discovered. And the first step into that new reality required answering the most fundamental question of all. How could you prove that the very ground you stand on, the world that feels so utterly and profoundly still, is in fact moving? For more than 2,000 years, the story we told ourselves was a comforting one. A story of stability, of importance, of a universe designed just for us. Earth did not move. It was the anchor of creation, the fixed stage upon which the grand celestial drama unfolded every night. The sun, the moon, the planets, the distant glittering stars, all were bound to intricate crystalline spheres turning in perfect circles, a divine clockwork with humanity at its very heart. It was a beautiful, magnificent, and profoundly wrong idea. The most dangerous thought in history did not arrive with an army. It was born in silence, in the quiet study of a Polish church official, a mathematician and astronomer named Nicolaus Copernicus. He looked at the established cosmos, the universe of Ptolemy, and he saw not divine perfection, but a clumsy, overwrought machine. To make the planets behave as we saw them, this ancient model needed gears within gears, epicycles and deferents, a maddeningly complex system of celestial contraptions designed to save the central, unmoving Earth. It worked after a fashion. It could predict where a planet might appear, but to Copernicus it felt ugly. A cosmic Rube Goldberg machine. He wondered if there was a more elegant solution, a simpler truth. What if you committed the ultimate heresy? What if you dared to dislodge the anchor of existence? What if you put the sun in the center and sent the Earth spinning and hurtling through the void as just another wandering planet? Suddenly, convoluted mathematics began to untangle. The baffling retrograde motion of Mars, its strange backward loop in the sky, was no longer a mystical detour. It was a simple illusion, the result of a faster Earth overtaking a slower Mars in a cosmic race. The entire celestial dance became simpler, more harmonious, more rational. This was not a theory born of new evidence. It was a revolution sparked by a desire for mathematical beauty. Copernicus had redrawn the map of reality, and in doing so, he had demoted us. We were no longer the stationary masters of the cosmos, but inhabitants of a moving vessel adrift in an incomprehensible vastness. This was a terrifying, humbling, and liberating realization. He knew the danger of his thoughts. He knew the fury it would provoke. For decades he kept his work on the revolutions of the heavenly spheres, circulating only among a trusted few, a whisper changing the world. He held back its publication until the very end of his life, allegedly seeing the first printed copy on his deathbed in 1543. The revolution had begun, but it was a silent one, a mathematical ghost haunting the edges of astronomy. An idea, no matter how elegant, is a fragile thing. Without proof, without tangible evidence, it can be dismissed as fantasy. For over half a century, the Copernican model remained a curiosity, a clever hypothesis for mathematicians to debate, but not a physical reality. The world needed a witness. It needed someone to look up and see the truth. That witness was an Italian firebrand, a brilliant and combative professor from Padua named Galileo Galilei. And his instrument of revelation was a new invention, a toy really, that Dutch spectacle makers had been selling as a novelty, a tube with two lenses, a spyglass. But in Galileo's hands, this simple device became a weapon, a tool for dismantling an ancient universe. He did not invent the telescope, but he was the first to truly understand its power. He perfected it, increased its magnification, and then did something unforgivably audacious. He pointed it at the heavens. He aimed it at those supposedly perfect, ethereal, unchanging lights. What he saw would shatter the foundations of the old world. First, he looked at the moon. According to the ancient doctrines of Aristotle, the moon was a flawless sphere, a smooth, polished orb of otherworldly substance. Galileo's telescope revealed a lie. He saw a world, a scarred, rugged, imperfect world. He saw towering mountains casting long, jagged shadows across dusty plains. He saw vast craters, the pockmarks of ancient collisions. It was a landscape, not an abstraction. It was a place just like Earth. The sacred barrier between the corrupt, changing terrestrial realm and the perfect, immutable celestial heavens had just been breached. If the moon was a world, then perhaps so was the Earth. But this was only the first crack in the great crystal spheres. The truly decisive blow came when he turned his gaze to Jupiter. He saw the great planet as a small, crisp disk, but he also saw something else, something unexpected and strange. 3 tiny, faint stars huddled close to Jupiter, all in a perfect line. He noted their positions, curious. The next night he looked again. They had moved, but they were still there, clinging to the giant planet. And now there was a 4th. Night after night, with mounting excitement, he charted their motion. They were not fixed stars. They were not wandering planets in their own right. They were dancing around Jupiter. They were in orbit around it. You have to imagine the sheer electrifying power of this discovery. For 2,000 years, all of philosophy, science, and theology had rested on the fact that everything in the cosmos circled the Earth. And here in the eyepiece of a small telescope was the undeniable proof that it was not true. Here was a miniature solar system, a perfect working model of the Copernican vision playing out in the heavens for all to see. These were Jupiter's moons. Worlds in their own right, tethered not to us but to another planet entirely. The universe did not revolve around humanity. The geocentric model was not just complex, it was fundamentally wrong. Galileo rushed his findings into a small book, The Starry Messenger, which exploded across Europe, making him a celebrity and a target. He had provided the first pieces of hard visual evidence, but he wasn't finished. There was one more observation, a final incontrovertible piece of evidence for his cosmic crime scene. He turned his telescope to the planet Venus. In the old Ptolemaic system, Venus was trapped on a complex path that always kept it between the Earth and the Sunday. If that were true, an observer on Earth should only ever see Venus as a thin crescent, or at best a half-lit disk. We could never see it fully illuminated, because its sunlit face would always be turned away from us. Copernicus's model made a different prediction. If Venus orbited the Sun inside Earth's own orbit, then like our Moon, it should display a full range of phases. When it was on the far side of the Sun from us, we should see it as a small but completely full shining disk. Galileo watched Venus night after night for months. He saw it shrink from a large crescent to a smaller gibbous shape, and then triumphantly into a tiny, perfect, fully illuminated circle. The case was closed. The Ptolemaic universe was dead slain by a few pieces of polished glass. Galileo had provided the visual proof, the smoking gun. He championed this new cosmology with passion, wit, and a dangerous lack of diplomacy. He argued not just that the Copernican system was a better model, but that it was the literal truth, a truth revealed by God's own handiwork in the heavens. This brought him into direct and disastrous conflict with the authorities of his time. He was summoned by the Inquisition, tried for heresy, and forced to recant. Under threat of torture, the old man, his eyesight failing, knelt and renounced the truth he had seen with his own eyes. Legend tells us that as he rose he muttered under his breath, epicycles, and yet it moves. The legend may be false, but its spirit is true. No authority, no doctrine, no threat could stop the Earth from moving. Galileo had shown us that our world was in motion, but an enormous question remained. How? How did the planets move? What path did they follow? Even Copernicus, the great revolutionary, had clung to one ancient assumption, the perfection of the circle. He had placed the Sun at the center, but he kept the planets orbiting in those flawless, divinely ordained circles. But it didn't quite work. The predictions were better, but still not perfect. Something was still wrong with the cosmic machinery. To find that final flaw required a completely different kind of mind. Not a bold revolutionary like Copernicus, nor a brilliant polemicist like Galileo, but a man who was equal parts mystic mathematician and obsessive detective. His name was Johannes Kepler. Kepler was driven by an almost mystical quest for cosmic harmony. He believed the universe was a reflection of God's mind, and that its structure must be based on perfect geometric forms. He spent years trying to fit the planetary orbits into a nested system of platonic solids, a beautiful but utterly incorrect vision. But unlike so many before him, Kepler had a secret weapon, a treasure trove of data of unparalleled precision. He had inherited the meticulous lifelong observations of the great Danish astronomer Tycho Brahe. Tycho had spent decades charting the positions of the stars and planets with a fanatical accuracy, creating a dataset that was the gold standard of its time. And it was within this mountain of numbers that the truth was hiding. Kepler decided to focus his formidable intellect on a single problem, the strange, stubborn orbit of the planet Mars. He began what he would later call his war with Mars. He assumed, like everyone else, that the orbit must be a circle. He calculated and calculated and calculated again. He filled nearly 1,000 pages with dense, painstaking arithmetic. For years he battled the data, trying to force Mars into a perfect circle. He came incredibly close. His best circular model matched Tycho's observations almost perfectly. Almost. There remained a tiny, infuriating discrepancy. A minuscule error of just 8 arc-minutes, 1/60th of a degree, a sliver of the sky so small it is barely visible to the naked eye. It would have been so easy to ignore it, to blame it on observational error. Any other astronomer probably would have. But Kepler trusted Tycho's data more than he trusted 2,000 years of tradition. He trusted the evidence more than his own cherished beliefs in divine perfection. That tiny error, he wrote, was a gift from God, a clue that would lead him to the reformation of all astronomy. He made a decision of monumental scientific courage. He threw out the circles. He abandoned the dogma of perfection. If the orbit wasn't a circle, what was it? He tried other shapes, other curves. The calculations were a nightmare. And then, after years of torturous effort, he found it. The answer wasn't a circle. It was a slightly squashed circle, an oval, an ellipse, with the sun not at the center but at one of 2 focal points. It was a revelation that changed everything. The planets did not move in perfect uniform paths. Their orbits were imperfect, elongated. This was Kepler's first great law. From it, a second law quickly followed. He realized that the planets did not move at a constant speed. They sped up as they swung in closer to the sun and slowed down as they moved farther away. They swept out equal areas of their orbit in equal times. There was a rhythm to the cosmos, a celestial tempo. The universe was not a simple turning sphere. It was a dynamic breathing system. Kepler had finally uncovered the true choreography of the solar system. He had discovered the hidden rules, the grammar of the planets. He had shown how the Earth and its siblings moved through space. But the ultimate mystery, the deepest question, still lingered. Why? What was this invisible tether that bound the planets to the sun? What was this mysterious influence that reached across millions of miles of empty space to guide worlds along their elliptical paths? Copernicus had redrawn cosmos. Galileo had seen it. Kepler had described its geometry. But no one had explained the force behind it all. The final piece of the puzzle, the grand synthesis, would require the greatest scientific mind that has ever lived. The story shifts now from the continent of Europe to an England recovering from plague and civil war. It leads us to a solitary, secretive, and astonishingly brilliant figure at Cambridge University, Isaac Newton. Newton was a universe unto himself. His mind seemed to operate on a plane far removed from ordinary human thought. While others had chipped away at the old cosmos, Newton would demolish it and build a new one in its place, all founded on a single, breathtakingly simple idea. The legend, of course, involves an apple. We picture him in a garden, seeing the fruit fall from a tree, and in a flash of inspiration understanding the secret of the cosmos. The reality was a lifetime of ferocious concentration and calculation, but the apple provides the perfect metaphor for his revolutionary insight. Newton looked at the falling apple and he looked up at the moon. People had always seen these as two completely separate phenomena, governed by two different sets of rules. One was terrestrial, mundane, a simple matter of things falling to earth. The other was celestial, mysterious, the province of divine forces. Newton's genius was to realize they were the same thing. He asked a question of sublime simplicity. If the force that pulls on the apple extends to the top of the tree, does it also extend to the top of the mountains? If so, how far does it go? Does it reach all the way to the moon? He reasoned that the moon is in fact constantly falling. It is falling towards the earth, pulled by the exact same force that tugs on the apple. But the moon is also moving sideways at an incredible speed. So as it falls, the curved surface of the earth falls away beneath it. It is in a perpetual state of falling, but never getting any closer. This is what an orbit is, a delicate balance between forward motion and a constant fall. The moon's graceful arc across the night sky and the apple's plummet to the ground were two expressions of the very same force. He called it universal gravitation. Universal, that was the key. It wasn't a special force just for the heavens or just for the earth. It was a property of all matter. Everything in the universe pulls on everything else. You are pulling on the earth. The earth is pulling on you. The sun is pulling on the earth, and the earth is pulling on the Sunday. Even the most distant stars are locked in this cosmic gravitational embrace. He then formulated this idea into a precise mathematical law. The force of gravity depends on two things, the mass of the objects and the distance between them. It was simple, elegant, and it explained everything. It explained why apples fall down and not up. It explained why the planets moved in Kepler's elliptical orbits, speeding up and slowing down, just as Kepler had described. Newton's law of gravity was the engine driving Kepler's celestial clockwork, but he provided one more crucial piece, the concept of inertia. An object in motion, he declared, stays in motion unless acted upon by an outside force. The Earth doesn't need angels to push it along in its orbit. Once set in motion at the dawn of the solar system, it simply keeps going. Gravity doesn't push it forward. It just continuously bends its path from a straight line into a vast, stable, elliptical orbit. In his monumental work, the Principia Mathematica, Newton laid it all out. He provided the mathematical language to describe a universe in motion. He unified the heavens and the earth under a single set of physical laws. The revolution was complete. In the space of just 150 years, we had gone from a species cowering at the center of a small confined universe to passengers on a small planet, one of many held in a precise gravitational dance around a star careening through a cosmos governed by knowable mathematical principles. We finally understood not only that the Earth moves, but how it moves and why it moves. We were no longer at the center of everything, but for the first time we were finally beginning to understand our true place in the universe. And we were ready to ask an even bigger question. If our Earth moves around the Sun, does our Sun also move? What is our true trajectory through the unimaginable depths of space? We have journeyed with our world on its grand elliptical path. We have felt the Sun's gravitational hand guiding us through the seasons. But this epic voyage around our star is only half of the story. The most profound motions, the ones that define our day and our destiny, happen not across the void, but right here beneath our own feet. For millennia we lived with a magnificent deception, a cosmic illusion so perfect, so complete, that it became the bedrock of civilizations, religions, and our very sense of self. The illusion of stillness. We awake and the sun climbs the eastern sky. It traces a majestic arc overhead, a fiery chariot on a celestial road before sinking into the west. cloaked in the colors of twilight. The stars, a glittering procession, follow in its wake. Everything in the heavens appears to move to circle us, everything except the ground on which we stand. That ground feels solid, immovable, the one fixed point in a swirling universe. This was not an assumption, it was an experience. It was the raw data of every human life that had ever been lived. To suggest otherwise was not just heresy, it was madness. It was to deny the evidence of your own senses. Copernicus could write the mathematics. Galileo could see the moons of Jupiter and the phases of Venus. They could argue with logic and inference that the Earth must spin, but their proof was indirect, written in the language of orbital mechanics. It failed to answer the simplest, most human question. If we are truly spinning at 1,000 miles per hour, why can we not feel it? Why are we not hurled into space by this incredible velocity? The answer, of course, is that everything is moving together. You, the air you breathe, the buildings, the oceans, the clouds, all are passengers on this planetary vessel sharing the same momentum. Like being in a perfectly smooth, windowless train car, you feel no sense of motion at all. The universe seems to glide past you. But how do you prove you are on a moving train if you can never get off? How do you unmask a motion that has become your definition of stillness? For centuries, this remained the elusive prize of physics. Direct, tangible, irrefutable proof of Earth's daily spin. It would take a different kind of genius to finally trap this ghost. Not an astronomer looking up, but an inventor looking down. A man obsessed with precision, with the delicate dance of gears and light. His name was Léon Foucault. In the charged, revolutionary air of mid-19th century Paris, he conceived an experiment of such breathtaking simplicity and elegance, it would forever change how humanity perceived its own world. He did not need a telescope or a complex equation. He needed only a wire, a weight, and a very high ceiling. He found his stage in the heart of Paris, beneath the colossal dome of the Panthéon, a place of secular saints, a temple to the giants of French thought. Here, in this grand hall, Foucault would stage a silent play in which the leading role was performed by the planet Earth itself. Imagine yourself there on a winter morning in 1851. A crowd has gathered buzzing with skeptical curiosity. Statesmen, artists, scientists, and citizens, all drawn by a strange promise to witness the Earth turn. From the center of the soaring dome, a steel wire 220 feet long plummets towards the floor, a lifeline to a fixed point in the heavens. At its end hangs a colossal brass-coated lead bob weighing 60 pounds. A wicked, beautiful sphere crafted to a perfect point. It is drawn back, tethered by a cord like a beast on a leash. The air is thick with anticipation. The hall is utterly silent. Foucault, with theatrical flair, takes a candle and burns the restraining cord. The connection is severed. The great pendulum is released into its own custody. It begins to swing. Slow, majestic, and unnervingly quiet. A silent metronome marking a cosmic rhythm. Back and forth it glides, a golden arc through the still air. Its sharp point traces a fine line in a bed of damp sand on the floor below. At first, nothing seems to happen. It is just a pendulum swinging, a beautiful, oversized toy. The crowd watches, mesmerized, but perhaps a little disappointed. But Foucault had asked for their patience. He knew the Earth's motion was subtle, its revelation a slow, creeping dawn. He had placed a series of small pegs like miniature bowling pins around the circle. Minutes crawl by. The pendulum continues its serene, implacable swing. Then a faint collective gasp ripples through the hall. The plane of the pendulum's swing seems to have shifted just slightly. It is no longer swinging along its original line. It is now on a collision course with one of the pegs. With agonizing slowness, the arc of the swing creeps closer and closer, and then with a soft click it happens. The pendulum's point topples the first peg. A profound, impossible thing has just occurred. No one touched the pendulum. No gust of wind disturbed its path. Its swing, governed by the pure laws of inertia, should be immutable. The direction of its swing should remain fixed forever. Yet, undeniably, from the perspective of everyone in the room, it was turning. Slowly, inexorably, it was rotating clockwise. Click, another peg falls, and another, and with each fallen peg, a revolutionary truth solidified. The pendulum was not turning at all. We were. The floor of the Pantheon, the city of Paris, the continent of Europe, the entire planet was rotating beneath the steadfast swinging pendulum. Foucault had found a way to anchor his experiment, not to the Earth, but to the fixed inertial framework of the distant stars. The pendulum's swing maintained its original direction in absolute space, while the Earth, our supposedly solid ground, majestically pirouetted under it. In that hushed hall, people were not just observing a clever physics demonstration, they were experiencing a profound and dizzying reorientation of reality. For the first time in history, human beings could watch their own planet move. They could see with their own eyes the silent, relentless turning of their world. The ground was not firm, the foundation was not stable. It was a deck, the deck of a colossal ship, sailing not on water, but on the currents of space-time, spinning as it goes. The great deception was over. The ghost was finally captured, made visible in the sand by a simple swinging ball. Earth's daily rotation was no longer a theory to be debated by astronomers. It was a public spectacle, a truth laid bare for all to see. But this daily spin, this swift and steady pirouette, is not the only motion of our world. Earth's dance is more complex, more nuanced than a simple rotation. There is another movement woven into the fabric of our planet's being, a motion so slow, so subtle and grand that it went unnoticed for millennia, a ghostly wobble, a celestial nod that unfolds over an almost unimaginable timescale. To find the first clues of this deeper rhythm, we must leave the bright halls of Paris and journey back 2,000 years to the shores of the ancient Aegean. Here, under the pristine skies of the Hellenistic world, a man was undertaking a task of monumental ambition. His name was Hipparchus of Nicaea, perhaps the greatest observational astronomer of antiquity. Without a telescope, armed only with simple sighting tools and a brilliant mathematical mind, he was charting the heavens with unprecedented precision. He was creating a definitive map of the stars, a catalogue of their positions that he hoped would serve as an eternal reference for all future generations. It was in comparing his own meticulous observations with older Babylonian records that he stumbled upon a profound and deeply unsettling discrepancy. The stars were not where they were supposed to be. The shift was tiny, almost imperceptible, but it was systematic. The entire celestial sphere seemed to have drifted ever so slightly with respect to the seasons. Specifically, Hipparchus noted that the position of the sun against the backdrop of the stars at the moment of the vernal equinox, the first day of spring, was slowly shifting backwards through the constellations of the zodiac. Each year, spring arrived a tiny fraction of a degree earlier in the planet's orbit. This effect, which he named the precession of the equinoxes, was a cosmic scandal. The heavens, thought to be perfect and unchanging, were in flux. Think of the sheer genius this required. He was detecting a motion that takes nearly 26,000 years to complete a single cycle. He did it by comparing just a century or two of astronomical data. It was like trying to measure the speed of a continent drifting by watching a crack in a wall for only a few minutes. Hipparchus had discovered one of Earth's deepest and most secret movements. He had found a fingerprint, a clue to a crime against celestial perfection, but he could not identify the culprit. He knew what was happening, but he had no way of knowing why. What colossal unseen force could be powerful enough to twist the entire cosmos, or more accurately, to slowly alter the orientation of the Earth itself? For nearly 2,000 years, this great celestial drift remained an unsolved, riddle, a known fact of astronomy without a physical explanation. It was a ghost in the machine of the solar system, its cause shrouded in mystery. The answer would have to wait for the arrival of another towering intellect, a mind capable of weaving together the motions of planets and the fall of an apple into a single universal theory. It was Isaac Newton who finally cracked this ancient case. With his law of universal gravitation, he had the key not just to the orbits of planets but to their more intimate behaviors as well. Newton realized that the cause of this grand, slow wobble lay in a conspiracy of three factors: Earth's shape, its tilt, and the relentless pull of its neighbors. First, the shape of our world. Earth is not a perfect sphere. Its rapid daily rotation causes it to bulge slightly at the equator. It is an oblate spheroid, a little bit wider than it is tall. This equatorial bulge, though minor, is crucial. It is the handle that gravity can grab onto. Second, our planet's tilt. As we know, Earth's axis is not perpendicular to its orbital plane. It is tilted by about 23.5 degrees. This tilt is what gives us our seasons, our summers and winters, but it also means that the bulging equator is not aligned with the rest of the solar system. And this is where our celestial neighbors come in. The Sun and the Moon, the two dominant gravitational forces in our vicinity, do not pull on the Earth perfectly evenly. Their gravity tugs more strongly on the side of the equatorial bulge that is closer to them. They are constantly trying to correct our planet's posture. Their combined gravity exerts a gentle but persistent torque on the Earth, attempting to pull that tilted bulge back into alignment to straighten our planet up so its equator lies flat on the orbital plane. If the Earth were not spinning, this gravitational tug-of-war would simply change our planet's tilt over time. But Earth is spinning and spinning with incredible speed and power. This rotation endows our planet with immense angular momentum. It transforms our world into a colossal gyroscope, and anyone who has played with a spinning top knows the magic of a gyroscope. When you give a spinning top a gentle push trying to knock it over, it doesn't simply fall, it resists. It defies the push in a strange and beautiful way. Instead of tipping, its axis of rotation begins to slowly trace a cone. It begins to wobble. This motion is called precession. Our Earth is that spinning top. The gravitational pulls of the Sun and Moon are the gentle, relentless fingers trying to tip it over. And because our planet possesses the immense stability of a gyroscope, it responds not by straightening up, but by wobbling. The axis of rotation, the imaginary line running through the north and south poles, does not stay pointed at a single spot in the heavens. Instead, it slowly, majestically traces a great circle against the backdrop of the stars. A single one of these cosmic wobbles, one complete circle, takes 25,772 years. This is the solution to Hipparchus's ancient mystery. This is the source of the precession of the equinoxes. Our planet is perpetually nodding a slow gyration in the face of cosmic forces. It is a motion of almost incomprehensible slowness, a deep planetary sigh. Yet its consequences are profound, shaping our history and our future. The most immediate effect is that our guiding star is not permanent. Right now, Earth's North Pole points almost directly at a modest star in Ursa Minor Polaris. It is our North Star, the linchpin of celestial navigation, but it is a temporary guide. As the Earth's axis wobbles, it will slowly drift away from Polaris. 13,000 years from now, at the halfway point of this great cycle, our North Pole will point towards the brilliant blue-white star Vega. Navigators of a distant future will look to a completely different sky. And looking back, we know that the ancient Egyptians who built the pyramids looked up to a different pole star as well, a star called Thuban in the constellation Draco. The very heavens are not constant. The celestial map changes with the slow, patient rhythm of this cosmic gyre. This wobble also subtly alters the relationship between our seasons and our orbit. It is one of the key drivers of the Milankovitch cycle's long-term variations in Earth's orbit and orientation that are believed to orchestrate the Great Ice Ages. This slow 26,000-year wobble is not just a celestial curiosity. It is a planetary metronome, a deep bass note in the climate symphony of our world, driving epochs of glacial expansion and warm interglacial periods like our own. So we find ourselves on a world of nested, intricate motions. We are not standing on solid ground, but on the surface of a dynamic engine, a spinning top completing a full rotation every 24 hours, giving us the rhythm of day and night. And this spinning top is also wobbling, tracing a grand, slow circle that redraws our star maps over millennia. Each movement, from the swift daily turn to the slow processional nod, was once a profound secret, a mystery hidden by the sheer scale of the cosmos. They were solved not just by equations, but by human ingenuity, by a pendulum swinging in a Parisian hall, and by ancient eyes charting the slow drift of the stars. We have peeled back the layers of our own planet's dance, the spin, the tilt, the wobble, but we are still not seeing the full picture, because our entire world, this intricate spinning gyroscope, is itself a passenger on a much larger vessel. It is caught in a celestial current, a river of stars pulling our sun and all its planets on a voyage towards a destination we are only just beginning to comprehend. Our journey is far from over. The grand familiar motions are now part of our story. We have felt Earth's spin and traced its celestial waltz. We have followed its long looping journey around our star. But this cosmic clockwork, as regular as it seems, is an illusion. It is the simple face of an impossibly complex machine. Beneath the steady rhythm of day and night, our world quivers. Below the predictable procession of the seasons, it shudders. There are other movements, secret and profound, motions so subtle they went unnoticed for millennia. So slow they make a human lifetime feel like a fleeting spark. These are the hidden tremors of a living, breathing planet. They are the clues that reveal Earth is not a solid, rigid ball. It is something far more dynamic, more fluid, and more alive. To find these motions, we must look past the heavens. We must turn our gaze inward to the very substance of our world. For over a century, astronomers tracked the stars with precision. They mapped their positions to tiny fractions of a degree. Their work confirmed the Earth's rotation with exquisite accuracy, a steady, reliable spin that defined our very concept of time. But in the late 1800s, a nagging anomaly appeared, a tiny, inexplicable error that refused to be ignored. The stars, from our perspective, were not staying perfectly still. They seemed to drift just a little in a small looping pattern. This suggested that the North Pole was not a fixed point on the globe. It was wandering, tracing a slow, irregular circle. The entire planet was wobbling like a slightly unbalanced top. Seth Carlo Chandler, an American astronomer, dedicated himself to this puzzle. He sifted through mountains of data, chasing a ghost in the numbers. He found a recurring oscillation, a planetary stutter, a wobble with a period of about 14 months. It was a departure from perfection, so small it was almost negligible. The pole was shifting by no more than a few meters, a distance you could walk in a matter of seconds. Yet this tiny imperfection was a profound revelation. It was the signature of a world far more complex than we knew. A perfectly solid, rigid sphere would not wobble like this. Its spin would be as pure and unwavering as a law of physics. But Earth, we were beginning to understand, is not solid. The Chandler wobble was the first clear proof. It was the planet's way of telling us about its secret interior. This faint quiver is a conversation between all of Earth's parts. It's driven by the sloshing of water in our vast ocean basins. It's influenced by the shifting weight of our atmosphere, pressure systems swelling over continents and then dissipating, great masses of air moving and reshaping the planet's balance. Even the seasonal accumulation of snow and ice plays its part. But the true conductor of this unsteady symphony lies deeper, deep in the unimaginable heat and pressure of the planet's core. The wobble is sustained by the churning of a liquid iron heart, a molten outer core swirling around a solid inner sphere. This is not the motion of a simple spinning rock. This is the complex, interconnected motion of a dynamic system, a planet with a restless atmosphere, surging oceans, and a fluid heart. Each component pushes and pulls, minutely altering the spin. The Chandler wobble is the sum of all these hidden agitations. It is the faint, irregular heartbeat of a geologically active world, a world that is constantly shifting, deforming, and redistributing its own mass. This subtle dance, this planetary tremor, was a hint. It was a clue that the very ground we stand on might not be so solid after all. It opened the door to an idea far more radical, a motion so vast and slow, it seemed to be an utter fantasy. The idea that the continents themselves are in motion. Look at a map of the world. Let your eyes drift across the great oceans that separate the land. Notice the eastern coastline of South America. See how the great bulge of Brazil seems to yearn for Africa. Trace the sharp coast of West Africa, a concave curve. It is a near-perfect mirror to the shape of the Americas. They look like scattered pieces of a colossal shattered puzzle. A child could see it. For centuries, cartographers and thinkers had noted the resemblance, but it was dismissed as a mere coincidence, a trick of the eye. The continents, after all, were permanent fixtures. They were the very definition of immovable, rooted in the planet's foundation. To suggest otherwise was not science, it was myth. But in the early 20th century, one man refused to accept the coincidence. His name was Alfred Wegener, a German meteorologist and explorer. He was not a geologist, he was an outsider, and perhaps that is why he could see what the experts could not. Wegener looked at the world map and saw more than a puzzle. He saw a crime scene with the evidence scattered across the globe. He proposed a breathtaking, almost heretical idea. He suggested that all the continents were once joined together, a single gigantic supercontinent he named Pangaea, and that over hundreds of millions of years they had drifted apart. They had journeyed across the face of the planet to their current positions. He called his theory continental displacement, what we now call continental drift. It was an idea of such magnificent scale it bordered on insanity. But Wegener was a meticulous scientist. He knew a picture was not enough. He needed proof. So he began a lonely, obsessive quest to assemble the scattered clues. He went far beyond the jigsaw puzzle fit of the coastlines. He hunted for fossils, for the ghostly imprints of ancient life. He found the remains of the Lystrosaurus, a hippo-like reptile. Its fossils were unearthed in the soils of Africa, India, and Antarctica. These locations are now separated by thousands of miles of treacherous ocean. Lystrosaurus was a land animal. It could not have swum those vast distances. To Wegener, the only explanation was that these lands were once connected. The creatures had simply walked from one to the other. He found evidence of tropical plants like the Glossopteris fern. Fossilized leaves were discovered in the frozen wastes of Antarctica, and also in South America, Africa, India, and Australia. How could a tropical fern grow near the South Pole? It couldn't. But if Antarctica was once part of a larger continent, if it was once located in a warmer, more temperate climate, then the mystery would be solved. The fossils were witnesses to a world that no longer existed. A world where today's continents were neighbors on a single great landmass. Wegener then turned to the rocks themselves, the planet's memory. He traced the line of the Appalachian Mountains in North America, a colossal range worn down by eons of erosion. He noted that their geological structure, their age and composition, were stunningly similar to the Caledonian Mountains in Scotland and Scandinavia. It was as if a single immense mountain chain had been torn in two. its fractured halves carried away on drifting continents. He found more glacial scars, deep gouges in the bedrock. These ancient ice sheet tracks were found in southern Africa and South America. Today, these regions are warm, even tropical, but the scars pointed to a time when they were covered in ice. When Wegener plotted their locations on his Pangaea map, the scars all made sense. They radiated outward from a single polar ice cap. He was reassembling the planet's past piece by piece. The fossil record, the geological structures, the climate data, all of it pointed to one impossible conclusion. The continents moved. Wegener presented his formidable body of evidence to the world, and the world for the most part laughed. The scientific establishment of the day was built on a different idea, the belief in a static, permanent Earth. Geologists believed the planet was slowly cooling and contracting. Mountains were wrinkles forming on a shrinking surface like the skin of a dried apple. Oceans and continents were fixed primordial features. Wegener's theory was a direct assault on this entire worldview. He was accused of being a dilettante, a meteorologist meddling in geology. His ideas were dismissed as delirious ravings and poetic nonsense. The attacks were not just scientific, they were personal and vicious. The core of their rejection centered on one powerful question, a question Wegener could not satisfactorily answer. What force could possibly be powerful enough to move a continent? How could a landmass made of solid granite plow through the dense rock of the ocean floor? The physics simply did not work. Wegener proposed several potential mechanisms: the centrifugal force of the Earth's rotation or tidal forces from the Sun and Moon. But his calculations were wrong. These forces were far too weak. Without a plausible mechanism, his mountain of evidence was dismissed. It was a collection of fascinating coincidences, nothing more. Alfred Wegener spent his life defending his theory. He tirelessly updated his book, adding new evidence as he found it. He argued his case at conferences, facing down a wall of skepticism. In 1930, he embarked on his final expedition to Greenland. He died there, lost in a blizzard, while trying to resupply his colleagues. He passed from the world a lonely and ridiculed figure. His revolutionary idea, the slow dance of the continents, died with him, or so it seemed. He had planted a seed of doubt, a question that would not go away. The puzzle pieces he had gathered still lay on the table. The mystery of the matching coastlines and scattered fossils lingered. For decades, continental drift was relegated to the fringes of science, a cautionary tale of brilliant but misguided speculation. Then the world went to war, and in the aftermath of that global conflict, a new age of discovery began. An exploration that would take us to the one place on Earth we knew almost nothing about: the deep, dark floor of the oceans. During the Second World War, new technologies were forged in the crucible of conflict. One of the most important was sonar, the ability to map the unseen depths using sound waves. After the war, scientists turned this technology from hunting submarines to exploring the Earth. For the first time, we could peel back the water and see the true face of our planet. What we found there was not the flat, featureless plain that everyone had expected. It was a world of incredible geological violence and majestic beauty. A world of towering mountains, deep trenches, and vast volcanic plains. And running down the center of the Atlantic Ocean like a giant seam was something astonishing. A colossal underwater mountain range snaking its way around the entire globe, the Mid-Atlantic Ridge. This was not a passive feature, it was geologically active. Scientists discovered it was a place of intense volcanic eruptions and frequent earthquakes. It was a wound in the Earth's crust where something was happening. In the 1,960 seconds, a geologist named Harry Hess, a former submarine commander, contemplated this new strange map of the ocean floor. He remembered Wegener's ridiculed theory, and in a flash of insight he saw the missing piece of the puzzle. He realized the continents were not plowing through the sea floor, The seafloor itself was moving. Hess proposed a radical new idea he called seafloor spreading. He suggested that along these mid-ocean ridges, molten rock from the mantle was constantly rising up to the surface. As this magma cooled, it formed new oceanic crust. This process acted like a giant conveyor belt. The new crust continuously pushed the older crust away from the ridge on both sides. The continents were not the engines of this motion. They were merely passengers carried along for the ride. They were embedded in larger slabs of the Earth's crust, colossal plates being pushed and pulled across the planet's surface. This was the mechanism Wegener had been searching for, a force born not from the heavens but from the fiery heart of the Earth itself. It was a brilliant and elegant theory, but like Wegener's, it needed definitive proof. That proof would come from one of the most subtle forces in the cosmos, the Earth's magnetic field. Our planet acts like a giant bar magnet with a north and south pole, but this magnetic field is not stable. Throughout geologic history, it has unpredictably flipped. North has become south, and south has become north hundreds of times. When volcanic lava erupts and cools, tiny magnetic minerals within the rock behave like microscopic compass needles. They align themselves with the direction of Earth's magnetic field at that moment. Once the rock solidifies that magnetic orientation is frozen in place, it becomes a permanent record, a magnetic snapshot of the past. If seafloor spreading was real, there should be a record of these flips in the ocean crust. As new crust formed at the mid-ocean ridge and spread outwards, it would capture the magnetic field's orientation at the time of its birth. What scientists should find was a pattern of magnetic stripes, bands of rock with normal polarity, followed by bands with reversed polarity. And this pattern should be a perfect mirror image on both sides of the ridge. In the late 1960s, ships towing sensitive magnetometers crisscrossed the oceans. They were listening for the faint magnetic whispers locked in the seafloor rock. When they processed the data, the result was breathtaking. The stripes were there, perfectly symmetrical, perfectly clear, a stunning, undeniable barcode of geologic time. It was the geological tape recorder of a moving planet. The Earth itself was providing the testimony. The seafloor was spreading. The plates were moving. Wegener had been right. In a few short years, a scientific revolution swept the globe. The theory of continental drift was reborn as plate tectonics. It was a unifying theory that suddenly made sense of everything. It explained why earthquakes and volcanoes occur in specific bands. They happen at the boundaries where these colossal plates grind together. It explained how great mountain ranges like the Himalayas were formed, pushed up as the Indian plate crashed, and still crashes into the Eurasian plate. It explained the existence of deep ocean trenches, places where old oceanic crust is forced back down into the mantle to be recycled. The Earth was not a static museum of ancient features. It was a dynamic, endlessly churning engine, a planet whose surface is a mosaic of about a dozen major plates, all floating on the hot, soft, slowly flowing rock of the mantle beneath. Their motion is imperceptibly slow, measured in centimeters per year, about the same speed that your fingernails grow. But over the vast expanse of geologic time, this slow, relentless creep has completely reshaped the face of our world. It has opened and closed entire oceans. It has raised mountains to the sky and ground them down to dust. It has carried continents from the poles to the equator and back again. The Chandler Wobble showed us a planet with a fluid, restless interior. Plate tectonics revealed the ultimate expression of that restlessness, a planetary skin that is constantly in motion. The ground beneath your feet is not ground at all. It is the surface of a gigantic raft, a tectonic plate. It is journeying across a sea of semi-molten rock. Right now, North America is moving away from Europe. The Atlantic Ocean is widening year by year. The Pacific is shrinking. Africa is slowly colliding with Europe, building the Alps ever higher. This is the Earth's grand, slow dance. A motion so powerful, it builds worlds, and so patient it is invisible to us. We are living on a planet that is remaking itself day by day. The world you were born on is not in a very real sense the same world that exists today. It has shifted just a little, and in the deep future it will be a world transformed. A world with new oceans, new mountains, and new continents. The legacy of these sleepy scientists, Chandler and Wegener, was to awaken us to this profound and humbling truth, that stability is an illusion, and that our home is a world of constant, beautiful, and inexorable change. You believe you are sitting perfectly still. You feel the solid certainty of the ground beneath you, the unshakable foundation of a world that does not move. But this profound sense of stability is perhaps the greatest illusion your mind has ever constructed. Every story we have told on this journey, every motion we have unveiled, is happening to you at this very moment. You are spinning at 1,000 miles an hour. You are hurtling through space at 67,000 miles an hour. You are wobbling, nodding, and drifting across a continent. You are a passenger on a world in perpetual, complex, and beautiful flight. For millennia, this was a truth felt only in the abstract. A magnificent clockwork calculated on paper, inferred from the stars. But we live in a new age, an age where we have built ourselves new senses, senses of extraordinary precision capable of perceiving the imperceptible. We have taught machines to listen for the planet's subtlest whispers, to feel its faintest tremor, to weigh its shifting burdens. We have, in essence, learned to take the pulse of a living world, and in doing so we have unveiled a portrait of our Earth far more dynamic, more intricate, and more alive than we ever dared to imagine. Our quest to map this symphony of motion begins not on Earth, but in the impossibly deep past at the very edge of the cosmos. Out there, in the violent hearts of primeval galaxies, burn the most powerful and distant objects we have ever known. They are called quasars, blazing galactic nuclei powered by supermassive black holes so luminous they outshine everything around them, so far away that their light has traveled for billions of years to reach us. And because of that immense distance, they are, for all intents and purposes, the truest fixed points in the entire universe. Ancient lighthouses in the cosmic ocean, humanity has always sought such an anchor. The ancient Greeks looked to the fixed stars of the constellations. But we eventually learned those stars are not fixed at all. They are our neighbors in the Milky Way, drifting just as we are. Finding a truly stable backdrop against which to measure our own motion was a problem that vexed astronomers for centuries. Quasars are the definitive solution, and our method for using them is a breathtaking feat of global engineering. It is called Very Long Baseline Interferometry, or VLBI. Imagine a network of colossal radio telescopes scattered across continents, one in the deserts of New Mexico, another in the forests of Germany, one in the plains of Australia, another perched in the Chilean Andes. They are not separate observers. Through atomic clocks and fiber optics, they are linked together. They become a single planetary scale instrument, a virtual telescope the size of the Earth itself. This global ear is turned to listen to the faint ancient radio whispers arriving from a single distant quasar. Because the telescopes are thousands of miles apart, that signal does not arrive at each one at the same instant. There is a delay, a tiny infinitesimal lag measured in nanoseconds, a timing difference smaller than the blink of an eye. But within that delay is a universe of information. By measuring it with atomic precision for multiple quasars, scientists can calculate the exact distance between those telescopes down to the millimeter. Think about that. We can measure the distance between Europe and North America with a precision finer than the thickness of your fingernail. This technique is the bedrock, the absolute gold standard for our understanding of the Earth as a dynamic object. VLBI is the ultimate cosmic surveyor's tool. When we see that millimeter-precise distance between two telescopes change, we are not witnessing an error in measurement. We are watching continental drift in real time. We are watching the slow, inexorable dance of the tectonic plates, the fundamental engine of our planet's geology, unfolding not over geological time, but from one year to the next. We are seeing the Atlantic Ocean widen inch by inch. We are observing the Pacific plate grind against the shores of Japan. This is geology happening on a human timescale. But VLBI's revelations go even deeper. By anchoring our measurements to these motionless quasars, we can track the true orientation of our planet in space. We can finally see the subtle wobbles and nods of its spin axis with a clarity that was previously impossible. The grand 26,000-year cycle of precession, the delicate 18-year nodding of nutation, the tiny irregular Chandler wobble. These are no longer just elegant theories or long-term averages. They are tangible movements measured day by day. The data from this global network of telescopes forms what is known as the International Celestial Reference Frame. It is the most stable, most absolute map of the heavens ever created, a foundational grid against which all other motion of our planet, our solar system, and our galaxy can be measured. We have built an anchor in the cosmos, and with it we have discovered that the ground beneath our feet is anything but stable. While VLBI anchors us to the cosmos, another technology has cast a fine, invisible net around the entire globe, monitoring every tremor, every strain, every subtle breath of the crust. You know it as GPS, the Global Positioning System. For most of us, it is a familiar voice in our car, a blue dot on a map on our phone, a simple tool for navigating the surface of our world. But its true purpose is far more profound. The GPS network is a scientific instrument of planetary scale, a constellation of satellites each, a flying atomic clock broadcasting exquisitely timed signals down to Earth. On the ground, thousands of scientific-grade receivers bolted to bedrock on every continent listen silently. They are not interested in finding the nearest coffee shop. They are designed to determine their own position in three-dimensional space with a consistency and precision that is almost beyond belief. They pinpoint their locations so accurately they can detect movements smaller than the width of a human hair. This global network is our planet's nervous system. Every day it gives us a high-definition bulletin on the secret life of the Earth's crust. We can now watch as the colossal tectonic plates jostle for position. We see the ground in Iceland stretching apart as the mid-Atlantic ridge pushes North America and Eurasia away from each other. We can measure the strain building up along the San Andreas Fault in California as the land west of the fault line creeps relentlessly northwest towards Alaska. This is no longer the domain of geologists inferring movement from ancient rocks. We are measuring the forces that build mountains and trigger earthquakes moment by moment. We are eavesdropping on the conversation between continents. The sensitivity of this system reveals motion's even more subtle movements driven not by the planet's molten heart but by the ephemeral cycles of water and ice upon its surface. In places like Scandinavia and Canada, the ground is rising. GPS stations there are lifting upwards by several millimeters each year. They are measuring a process known as post-glacial rebound. The land is still springing back, breathing a slow sigh of relief from the crushing weight of the ice sheets that vanished over 10,000 years ago. We are watching the geological memory of the last ice age play out in the 21st century. The planet's surface is not just a solid, rigid shell, it is elastic, it breathes. GPS receivers can feel the entire North American continent flex under the weight of winter snowpack. They can measure how the crust sags and rebounds. In the Amazon basin, the ground itself rises and falls with the seasons as trillions of tons of water arrive with the yearly floods, and then recede, a hydrological pulse felt by the very bedrock. And perhaps most fundamentally, this constant conversation between satellites and ground stations provides one of our best measures of the Earth's rotation, the very definition of our day. Tiny, unpredictable changes in the speed of Earth's spin caused by the sloshing of its liquid core, the circulation of the oceans, and shifts in atmospheric patterns make the length of a day fluctuate by fractions of a millisecond. GPS helps us track these variations, forcing us to add a leap second to our clocks every few years to keep our time in sync with our planet's ever so slightly unpredictable celestial dance. We have wrapped our world in a web of measurement, and it has shown us a planet far from the steady clockwork orb of old. It has revealed a world that flexes, stretches, and breathes in a constant rhythmic cycle. But to get a truly complete picture, we needed to go beyond just measuring positions on the surface. We needed to learn how to weigh the world from space, to track the unseen movements happening below the crust, to follow the shifting burdens that make the planet groan and flex. To do this, we launched one of the most elegant and ingenious missions in the history of Earth observation. It was called GRACE, the Gravity Recovery and Climate Experiment, and it consisted of two identical satellites flying one behind the other in the same polar orbit. They were nicknamed Tom and Jerry, locked in a perpetual chase around the globe, about 140 miles apart. The satellites did not carry complex cameras or radars. Their only mission was to measure the distance between themselves with an obsessive, unbelievable precision. A microwave ranging system like a celestial tape measure constantly monitored the gap between them, sensitive enough to detect a change smaller than 1/10 the diameter of a human hair. Why this strange obsession with the space between them? Because that distance was not constant, it was always changing. And those changes were a direct map of the Earth's gravity field below. As the lead satellite, Tom, approached a region of slightly stronger gravity, a massive mountain range, for example, it would be pulled forward, accelerating just a tiny bit. The distance between it and Jerry would momentarily increase. Then, as Jerry passed over the same mountain, it too would accelerate, closing the gap once more. The two spacecraft were dancing to the silent music of gravity. Their ceaseless chase, their constant stretching and compressing, was translated by computers on the ground into a new map of the world. A map not of continents and oceans, but of gravity itself. A map of the planet's lumps and bumps, its dense regions and its lighter ones. But the true power of GRACE was not in a single map. It was in making that map again and again, month after month, year after year. Because by watching how the gravity map changed over time, we could do something that was once the stuff of science fiction. We could watch water move around the entire planet. For the first time, we could see the great ice sheets of Greenland and Antarctica, not just as static masses of white on a map, but as dynamic changing systems. The GRACE data revealed with chilling and undeniable clarity that they are losing billions of tons of ice every year. We were no longer estimating the loss, we were weighing it. We were watching the gravity signature of these regions literally fade as their mass drained into the ocean. The data took us underground. We could see the great aquifers beneath California's Central Valley in northern India being depleted by years of intensive agriculture. We could watch the gravity field weaken as vast stores of ancient water were pumped to the surface, a planetary resource vanishing before our eyes. We could track the epic deluges of monsoon season and the crippling droughts that followed. GRACE and its successor mission GRACE Follow On have given us a new way of seeing. They have rendered the invisible visible. They have shown us the planet's circulatory system in action, the ceaseless flow and ebb of the one substance that makes our world unique. They have revealed how the shifting weight of water and ice is a powerful driver of the planet's motion, distorting its shape and altering its very rotation. So we have an anchor in the cosmos, from VLBI. We have a nervous system on the surface from GPS. And we have a scale in orbit from GRACE. These systems and others like satellite laser ranging do not work in isolation. They are threads in a single, magnificent scientific tapestry. They are all woven together to create what may be humanity's most sophisticated model of our world, the International Terrestrial Reference Frame. This is not a simple map. It is not a static globe. It is a dynamic four-dimensional portrait of the Earth, a living database where every point on the planet is defined not just by a location, but by a velocity, a direction, and a speed through space. It accounts for the drift of continents. It incorporates the wobble of the pole. It tracks the rise and fall of the land. It is the ultimate synthesis of all our knowledge of how Earth moves. It is a monumental achievement, the result of decades of collaboration by thousands of scientists across the globe. It is the shared foundational understanding of our home planet. A planet revealed not as a solid, dependable rock, but as a fluid and restless world of breathtaking complexity. And all of it, every intricate motion on its surface, every wobble of its core, every gravitational breath is happening aboard a vessel on a much grander voyage. Because our entire world, our sun, our whole solar system is a tiny raft adrift in the currents of the Milky Way galaxy. We are orbiting the galaxy's enormous central black hole, a journey so vast it takes us over 200 million years to complete a single lap. Our cosmic year. We move along this path at a speed that is difficult to comprehend, nearly 500,000 miles per hour. We are not just moving in a flat circle. Our solar system also bobs up and down like a horse on a carousel, passing through the dense central plane of the galaxy's starry disk every 30 million years or so. We measure this immense journey by observing the stars around us, charting their movements relative to our own, and by looking at the faint afterglow of the Big Bang, the cosmic microwave background, which serves as a final, ultimate frame of reference for the universe itself. We stand here now on what feels like the firmest ground, but we know better. We know we are adrift on a tectonic plate, on a spinning, wobbling sphere that orbits a star that circles a galaxy that falls through the universe. There is no stillness. There is only the dance. A dance of nested motions, a symphony of cycles upon cycles, from the subtle flecks of the crust to the majestic sweep of the galaxy. The resolution to our story, the final answer to the question of how Earth moves, is not a single number or a simple direction. It is this picture, this new and astonishing portrait of a world alive with movement. For the first time in the history of our species, we have the tools to see it all. To measure the pulse of the oceans, the breath of the continents, the deep, slow rhythm of the solid Earth, we have learned that the only constant is change, and that our home is a place of perpetual, exquisite transformation. The more we measure, the more we see. And the more we see, the more we realize that the story of our planet's motion is still being written, and that we have only just learned how to read the opening chapter. And so, we arrive at the end of our voyage, not through space, but through the very heart of an idea so profound it reshaped our universe from the inside out. Take a moment. Feel the world around you. The unshakable solidity of the floor, the quiet stillness of the air. Everything in our immediate experience screams a single, simple truth: we are stationary. This ground is the bedrock of existence, the one fixed point. And yet you know now that this feeling is a magnificent deception. A trick of perception woven by gravity and immense scale. The profound stillness you feel is a lie. Right now you are a passenger on a colossal sphere of rock and iron. You are spinning on its axis at 1,000 miles an hour. You are hurtling around your star in a great sweeping ellipse. You are being dragged along with that star in a cosmic caravan, circling the monstrous black hole at our galaxy's core. And even that galaxy, our Milky Way, is not at rest. It is falling a river of 100 billion stars pulled by unseen cosmic currents toward a mysterious destination. This is the reality your mind now holds, a reality of ceaseless, layered, and spectacular motion, a kinetic truth that stands in stark opposition to every sensation your body reports from one moment to the next. The journey from that feeling of stillness to this complex truth was not a quick leap, but a slow, arduous climb. It is perhaps the greatest intellectual pilgrimage our species has ever made. It began in an age of myth, when the earth was a flat stage for the drama of gods and mortals, the sky a painted dome above. To suggest otherwise was not just wrong, it was madness. It was a violation of common sense, a heresy against experience itself. Our ancestors looked up and saw the sun's daily trek, the moon's changing face, the clockwork march of the constellations. The evidence for a stationary earth was overwhelming. It was everywhere written in the sunrise and the sunset, but quietly in the minds of a few scattered observers, a doubt began to fester. A question whispered across generations. What if the story our senses tell us is incomplete? What if the universe is not designed around our perspective? This is where our sleepy scientists enter the narrative. Not figures of sudden explosive genius, but of quiet persistence. They were people who chose the difficult path of measurement over myth. They were the patient watchers of the night, cataloguing the strange looping dances of the planets. They filled ledgers with numbers, charts with arcane symbols, driven by a faith that a hidden pattern, a deeper logic must exist. Think of them hunched over brass astrolabes in the chill night air, their only light a flickering candle. Imagine them spending decades on mathematical calculations that a modern student could complete in an afternoon. Their tools were primitive, their data often imprecise. They worked in isolation, separated by centuries and empires, yet they were partners in the same grand investigation. One would forge a single crucial link in a chain of reasoning. A century later, another thinker, perhaps reading a dusty translated text, would find that link and add another of their own. There was no single moment of revelation, no solitary eureka that suddenly illuminated the entire cosmic machine. Instead, it was a slow dawn breaking over the landscape of human thought. It was an inheritance of curiosity, passed from one inquisitive mind to the next. Copernicus, fearing ridicule, proposed a sun-centered system, a mathematical key that made the planetary motions simpler, more elegant. Tycho Brahe, not fully convinced, spent a lifetime accumulating the most accurate celestial measurements the world had ever seen, creating an arsenal of data without knowing which theory it would arm. Kepler, his student, inherited this treasure trove of numbers. He was the cosmic detective who, after years of grueling effort, discovered the crime scene was not littered with perfect circles, but with the subtle, beautiful geometry of ellipses. The universe, it turned out, was not just elegant, it was specific. Galileo turned a new invention, the telescope, to the heavens and shattered the old world forever. He found moons orbiting Jupiter, proving Earth was not the sole center of motion. He saw the phases of Venus, a spectacle only possible if it orbited the Sun, not the Earth. The evidence was no longer just in the mathematics, it was visible. And then Newton, who saw in the fall of an apple the same force that held the moon in its celestial tether. He gave us the language of this grand dance, gravity, a universal law that connected every object from a grain of sand to the most distant star in a ghostly choreography. Each of these figures, and countless forgotten others, were the sleepy scientists. Their work was not glamorous. It was obsessive, tedious, and often thankless. They were driven by a compulsion to reconcile what they saw with what they could reason. They were willing to abandon the comfort of certainty for the thrill of a deeper, more challenging truth. They taught us the most vital lesson in science, that the universe is not obligated to make sense to us on our terms. It is our job to adjust our thinking, to discard our most cherished intuitions when the evidence demands it. This quiet generational revolution in thought is a testament to the enduring power of sustained scientific inquiry. It shows that even the most fundamental self-evident truths can be overturned by careful observation and courageous thinking. The Earth is not the center. The ground beneath our feet is not still. These are not just facts, they are monuments to human intellect. But this story is not merely a historical curiosity. This intricate, hard-won understanding of Earth's multifaceted journey is more critical today than it has ever been. It has become the bedrock of our modern world, the essential lens through which we confront our greatest challenges and pursue our boldest dreams. Consider the defining challenge of our era: climate change. Our planet's climate is not a static system. It has always changed. The key to understanding its natural rhythms lies in the very motions we have explored. Subtle long-term shifts in our orbit, the slow wobble of our axis, the gentle tilt of our world. These are the components of the Milankovitch cycles. They are the great pacemakers of Earth's ice ages. For eons, they have governed the advance and retreat of glaciers, dictating the planet's long-term temperate patterns. Our sleepy scientists of geology and paleoclimatology, drilling deep into ancient ice cores and ocean sediments, have read this history chapter by chapter. They have learned to recognize the signature of these orbital mechanics. And because they understand this grand natural tempo, they can see with terrifying clarity how the current warming is a departure from that rhythm. We can see the spike in carbon dioxide is not part of the song, but a sudden discordant crash. Our knowledge of Earth's cosmic ballet is what allows us to diagnose the fever our civilization has induced. It provides the baseline, the control group against which we can measure our own profound and dangerous impact. Without understanding the planet's slow ancient dance, we would be blind to how terribly we are stepping on its toes. This same deep knowledge underpins our ability to anticipate the more immediate agitations of our world. The Earth's motion is not limited to its journey through space. The very ground we stand on is a mosaic of colossal plates drifting on a sea of molten rock. This is plate tectonics, the planet's own internal restless engine. The theory itself was another product of quiet, persistent work of scientists piecing together clues from fossil records, magnetic striping on the ocean floor, and the shape of the continents. They revealed a world constantly remaking itself. This understanding is not abstract. It is the foundation of survival. When we track the strain building along the San Andreas Fault or monitor the magma swelling beneath a volcano in Iceland, we are applying our knowledge of this planetary movement. Our GPS systems, which rely on exquisitely precise timing and an understanding of Earth's rotation and orbital position, can now measure the creep of continents millimeter by millimeter. This allows us to build better models, issue timelier warnings, and design infrastructure that can withstand the shudder of a planet that refuses to ever be truly still. We are learning to listen to the groans and shifts of our world, a skill born directly from the realization that stability is an illusion. And then there is our future beyond this world. Our journey to the moon, our robotic emissaries to Mars, the probes now sailing in the dark frontiers of interstellar space. Every single one of these ventures is a masterclass in the application of orbital mechanics. You cannot leave Earth without first knowing in exquisite detail exactly how it is moving. Imagine trying to step from one moving carousel onto another. Now imagine both are spinning, tilting, and racing along a curved track. That is the challenge of interplanetary travel. Mission planners at NASA and other space agencies are the direct intellectual descendants of Kepler and Newton. They do not just point a rocket at a planet and fire. They calculate a trajectory, a path through space-time. They must account for Earth's velocity in its orbit, its daily rotation, and the gravitational pull of the Sun, the Moon, and the destination planet. A launch window is not a matter of convenience. It is a precise moment when the complex dance of worlds aligns to make the journey possible. We use the gravity of other planets as a cosmic slingshot, a technique called a gravity assist to propel our spacecraft to the outer solar system. This is the ultimate expression of our understanding. We are not just passengers on a moving Earth. We are learning to use the motion of the entire solar system to our advantage. We have become choreographers in this cosmic ballet. Our ambition to become a multi-planetary species, to seek out new worlds and perhaps even new life, rests entirely on this foundation. It is a foundation laid by generations of sleepy scientists who simply wanted to know where we are and how we move. Their quiet, persistent questions have given us the stars. So we find ourselves in a remarkable position. We are a species that evolved to perceive a flat, stationary world, yet we have managed to uncover the spinning, orbiting, racing truth. We have peered through the veil of our own senses. We have constructed an understanding of reality that is far grander and more dynamic than we could have ever imagined. This knowledge has not diminished our world, it has magnified it. The ground beneath our feet is no longer just dirt and rock. It is the deck of a spaceship embarked on an epic and perpetual voyage. The sky above is no longer a simple ceiling. It is a window into the vast, intricate clockwork of the cosmos, a machine of which we are an integral moving part. We have learned that we are connected to everything. The same gravitational force that keeps us from floating into space is what orchestrates the waltz of galaxies across billions of years. The tilt of our planet, a seeming cosmic accident, is what gives us the changing seasons, the rhythm of life, death, and rebirth. We are the products of this motion. We are children of this celestial dance. And the journey of discovery is far from over. For all we have deciphered, for all the laws we have written, our planet and our universe continue to hold their deepest secrets. We still chase the enigma of dark matter, the invisible scaffolding that dictates our galaxy's grand rotation. We search for the source of dark energy, the mysterious force that is accelerating the expansion of the entire cosmos, pulling our galactic neighborhood toward an unknown fate. Here on Earth, we are still mapping the deep currents of the mantle and struggling to predict the chaotic flows of our atmosphere and oceans. The Earth continues its grand, silent ballet, and we are still just learning the steps. There will always be a need for new sleepy scientists. For the patient, the curious, the ones willing to spend a lifetime staring at the shadows to better understand the light. The ones who know that the greatest discoveries are not shouted from the rooftops but whispered in the quiet language of data, observation, and reason. So the next time you stand outside on a clear night and feel the profound, unshakable stillness of the world, smile at the beautiful deception. Know that you are riding a cosmic carousel of unimaginable speed and grace, a world in a constant state of falling, yet always catching itself, a planet on an endless pilgrimage through the quiet depths of space. And remember the quiet, persistent minds who over centuries of effort gave us the vision to see it, to see not a static rock, but a world alive with motion, a world that always has and always will have more to teach us.